Hello everyone, welcome to my channel. I'm Dr. Vivian. So in our previous videos, we already talked a lot about probabilities and what is a sample space, what is an event, and we also talk about some important rules of science. So in these videos, I will talk more about these topics. So about the intersections, unions, and complement of science. So in our last video, we already say the distribution law and the De Morgan laws of size. So in this one, let's look at this. If we have three sides, it's denoted by E1, E2, and E3. So here E1 is a circle on the top, and E2 is a circle on the left bottom, and E3 is a circle on the right bottom. Then, if we want to find what is area for the E1 intersection E2 intersection E3 in this one diagram picture, then what we should do, we should find the area covered by all of these three circles. So in this one, if we look at this one, the area will cover by all of these three circles is a part they will have the intersections in the center. So here I show this color by yellow. So you can see this yellow part is a part covered by all of these three circles. And then if we look at another part, so if we look at second one, what is the area about E1 intersection E2, but now intersection the complement of E3. So here we use C to denote the complement of E3. Then what this means? This means this part should be covered by the intersection of E1 and E2. So if we look at this graph, so the intersection of the circle E1 and E2 is a part we use the red color to shadow. So this is a part which is covered by two circles, E1 and E2. However, in the question, they say it's intersection by the E3 complement. So what this means? This means this result shouldn't have any intersection of E3. So that's the meaningful complement of the E3. So if we look at this one, the part originally we show this by yellow. This part shouldn't be shown in this intersection of E3 complement. So now for this question, this is area shown by the red color shadowed, and the first part is by the yellow color. And then now if we look at the question about third one, so now what is a E1 union E2 union E3 and then complement? Or if we have the De Morgan law, right? We can also find the part which is the fourth is E1 complement intersection E2 complement intersection E3 complement. So let's first look at the question part 3. So 3 is what we should do. We should look at the computation inside the parentheses first. So here inside the parentheses, this is E1 union E2 union E3. So that means this is area which is covered by either of these three circles. So it means this is a part, if we look at the picture, is a part will be shown by either three of these circles. So it will be some part inside this green color. So this any area inside this green color is our union of E1, E2, E3. And then the question is the complement of this union. So that means it's a part not inside this green color. So which is here, we will show this by the green shadow. So this is a part outside of our union. So here you can see this is everywhere outside of this green curve and inside our whole rectangle. Now this is a part for our question 3. Then how about question 4? So this is about the De Morgan law. So if we look at the De Morgan law, what we know De Morgan law give us this, in fact, is equal our part 3. Right, so based on this one, we will know, in fact, for question 4, the answer of this one is exactly same of our question 3. So that means this is a part covered by this green shadow. Okay, so now this is one example about how we can compute of some intersections, union, and complement of side. And here this example is not an easy one because now we have 3 sides. And also by the question 3 and 4, we give an example how we can use the De Morgan law to help us solve some questions. Okay, so this is about one example. And in this video, I want to have one more terminology about this. So the meaning of this is what means for the mutually independent, or here the mutually exclusive. So the part of this one is based on our computation of sides. So here if we have 2 sides, E1 and E2, so if the intersection of E1 and E2 is an empty side, so here this means an empty side. So sometimes we also call this as a non-side. So then we will say E1 and E2 are mutually exclusive. So this is a very important terminology for our probabilities and also for the computation of size. And if we show this by one De Morgan Venn diagram, then what this can have is if we have the whole of the space as a rectangle denoted by S, then if we have 2 circles, these 2 circles have no intersection. So that means if we look at the curve of the circle, they have no intersection. So this will mean our E1 intersection E2 is an empty side. So empty side means no area covered by both of these 2 sides, these 2 circles, or if we look at the materials of these 2 sides, then they don't share any common items. So this is about the mutual exclusive. So that's about our topics. So let me begin the end of this one. So here if we have our E1 is equal a side of only one element 4, and our E2 is equal a side of 4 and 5, and E3 is equal an element of only 5. So then what's the answer for E1 intersection E2? So this is the elements shown in both of these 2 sides. For this example, it means the answer of this one is number 4. And then what's the intersection of E1 and E3? then the answer of this one is what the elements show in both of these two sides. So if we compare E1 equal 4 and E3 equal 5, we will know there is nothing inside our intersection. So this is an empty set. And also this means these two sides is mutually exclusive. So it's mutually exclusive. And so this is one example about mutually exclusive. And then if we look at E2 intersection E3, then we will know E2 equal 4 and 5. E3 have only one element 5. So the common item here is number 5. So this means E1, E2 is not mutually exclusive. E1, E3 is mutually exclusive. And then E2, E3 the intersection is 5. So this is an example, one more example about size and the mutually exclusive. So if you like my video, please sum them up and also please subscribe my channel. So in the next videos, I will talk the multiplication rules of size and also probabilities. So thank you for your watching and see you in my next video.